Welcome to the DIY Honda Garage channel. The DTC P0116 refers to the Engine Coolant Temperature (ECT) Sensor 1 circuit range performance problem. This diagnostic trouble code indicates that the output temperature from ECT Sensor 1 is not fluctuating as expected under certain conditions. When the Powertrain Control Module (PCN) detects that the data from the ECT does not comply with its predefined parameters, it records the DTC to alert the technician to a potential issue within the cooling system. The ECT sensor plays a crucial role in monitoring the engine coolant temperature, which is essential for optimal engine performance and emissions control. It helps the PCM manage fuel injection, ignition timing, and the operation of the radiator fan. The sensor is typically located near the engine block and communicates temperature readings to the PCM through electrical signals. The Engine Coolant Temperature (ECT) Sensor 1 is a critical component that monitors the temperature of the coolant circulating through the engine. Its primary role is to send temperature data to the Powertrain Control Module (PCM), which adjusts engine operations according to the temperature readings. If this sensor malfunctions or produces inconsistent readings, the PCM registers a fault and triggers the DTC P0116. The sensor is usually located in the engine block or near the thermostat housing, where it can accurately gauge the coolant temperature. By checking this data, the PCM can make timely adjustments to fuel mixture, ignition timing, and even electric fan operation to prevent overheating. Therefore, any irregularities in the sensor's output signal can impact engine performance and reliability. There are several possible causes of the DTC P0116, which technicians should evaluate during troubleshooting. The first cause is a faulty Engine Coolant Temperature (ECT) Sensor 1, which may not accurately read the coolant temperature due to internal failure or mechanical wear. Secondly, wiring issues can arise, such as frayed, broken, or shorted wires, which can interfere with the signal sent to the PCM. Poor electrical connections, whether due to corrosion or loose terminals, can also contribute to erratic ECT sensor readings. Additionally, issues within the PCM itself could result in improper interpretation or processing of the ECT sensor data. Therefore, thorough inspection of both the ECT sensor and associated wiring is essential to identify the underlying cause of this DTC. Symptoms of DTC P0116 can manifest in various ways, notably affecting the vehicle's performance and operational efficiency. One primary symptom is engine overheating, which occurs if the PCM is unable to accurately assess coolant temperatures. This hampers the cooling system's effectiveness. Another potential symptom is poor engine performance, as incorrect temperature readings can lead the PCM to adjust fuel injection and ignition timing inaccurately, causing rough idling or decreased acceleration. Increased emissions may also be observed, as an improper air-fuel mixture can trigger exhaust irregularities. Furthermore, the check engine light may illuminate, notifying the driver of an active diagnostic trouble code. Awareness of these symptoms is key for timely diagnosis to prevent further engine damage. The first troubleshooting step involves starting the vehicle's engine. After turning on the ignition, the technician should allow the engine to warm up by raising the engine speed to 3,000 RPM, while ensuring the transmission is in park, P, or neutral, N. This condition simulates a normal operating environment. The next step is to monitor the Engine Coolant Temperature (ECT) Sensor 1 value using the Honda Diagnostic System (HDS). Observing the value during this process provides critical insights into whether the sensor is functioning correctly under load. If the readings from the ECT sensor remain static or deviate substantially from expected performance, it indicates potential sensor or circuit issues that need further investigation. This procedure establishes a baseline for comparative measurements in subsequent steps. Once the engine has been maintained at 3,000 RPM for a specific duration, the technician should let the engine idle for another 2 minutes. During this idle period, careful observation of the ECT Sensor 1 readings displayed on the Honda Diagnostic System HDS is essential. These readings indicate whether the sensor values are stable or fluctuating, providing further evidence of the sensor's performance. After the idle duration, the technician must turn the vehicle switch to off, lock mode, to prepare for the next diagnostic steps. This procedure is crucial because it allows the engine to cool down for assessment after verifying the sensor readings. Documenting the HDS values at this stage will help in determining any discrepancies upon reevaluation. After the engine has been allowed to idle and the vehicle is turned off, the next troubleshooting step is to allow the engine to cool completely for a minimum of 3 hours. This cooling phase is important to ensure that the fears of overheating do not confound the sensor readings later. Once the cooling period has elapsed, the technician should turn the vehicle to the on mode, but without starting the engine. At this stage, the technician must then retrieve the ECT Sensor 1 data using the Honda Diagnostic System HDS. Comparing the data collected now with the previously recorded values will illuminate any persistent issues relating to the sensor's functionality. This entire process helps identify whether the ECT Sensor 1 is performing effectively, regardless of previously noted conditions. The final step in troubleshooting for DTC P0116 involves assessing the temperature change of the engine coolant temperature, ECT Sensor 1 output. Specifically, the technician should check whether the HDS values indicate a change of less than 18 degrees Fahrenheit, 10 degrees Celsius after the engine cooling process. If this threshold is not met, it confirms that the fault was duplicated and common functionality issues persist within the ECT Sensor 1 circuit. This observation acts as critical evidence to conclude that a malfunction exists, necessitating further action. If the readings fall short of this benchmark, it validates the need for component replacement or more extensive electrical diagnostics. Hence, a systematic approach is essential to ensure that the exact problem is identified and addressed appropriately. After completing the necessary repairs for DTC P0116, it is crucial to conduct a final verification process to confirm that the issue has been resolved. The first step in this verification involves confirming that all repairs are satisfactory and that the ECT Sensor 1 has been replaced or repaired properly. Once confirmed, the technician should proceed to clear the stored DTC from the Honda Diagnostic System HDS to reset the vehicle's diagnostic memory. This step clears any fault codes logged during diagnosis, allowing the system to operate afresh. It is equally important to retest the vehicle's performance by observing the new ECT readings while performing similar engine operations as in previous steps. Successful completion of this verification ensures that the problem has been effectively addressed and the vehicle is operating normally. To minimize the chances of encountering DTC P0116 in the future, regular preventive maintenance is essential. One of the key practices is conducting routine checks on the engine coolant temperature, ECT Sensor 1, to ensure it is functioning correctly. Technicians should also inspect the associated wiring and connections for signs of wear, fraying, or corrosion. Ensuring that electrical connectors are tight and free from dirt and grime can significantly improve signal integrity and prevent premature sensor failures. In addition, maintaining the quality of engine coolant is crucial for the overall health of the cooling system. Using OEM, original equipment manufacturer, recommended fluid can help prevent corrosion and scaling inside the system. By adhering to these preventive maintenance steps, technicians can help ensure the longevity and reliability of the ECT sensor and supporting systems. In conclusion, understanding the role of the engine coolant temperature ECT sensor 1 is imperative for diagnosing DTC P0116 effectively. This sensor provides crucial temperature data that impacts engine performance and emissions control, thus making it essential for proper vehicle operation. Identifying common causes, such as faulty sensors or wiring issues, aids technicians in their approach to repairs. Furthermore, performing regular maintenance, including sensor checks and electrical inspections, can help prevent future occurrences of related DTCs. By following a structured troubleshooting process and understanding the underlying issues, repairs can be carried out efficiently, ensuring optimal vehicle performance and reliability. Employing preventive measures further enhances the sustainability of the vehicle's cooling system and reduces the likelihood of complications arising from similar faults. Please like and subscribe to the channel. See you next time.